Welcome to module 5 of programming in C++. We have been discussing various example programs that typically you have written in C, and now we are showing how they can be written equivalently in C++, how often the C++ standard library can be used for it, and with that we would like to show how C++ enhances the ease of programming. So, in this module we will talk about stacks and its applications. We will try to understand the implementation and use of stack in C, which I presume all of you know, and then we will show how in C++ the standard library can be used for doing stacks. So, these are the topics. We will primarily use reversing a string and evaluating a postfix expression as examples. So, just to recap on the introduction of stack, stack is as we know is a LIFO structure, last in first out container that maintain a collection of arbitrary number of data items. There is no restriction like in array. There is a restriction of how many elements I can keep depending on the size of the array. Stack by definition is unbounded. All elements, data elements that I keep in a stack have to be of the same type, but I can keep any number of elements. So, to create a stack in C, we need to do, these are the common steps that we will need to follow. First, we need to decide on the data type of the element, define a structure or container. For actually defining that in C, we will need to use some maximum size, otherwise the C compiler will not allow us to define it. Declare a top variable which will maintain the top of the stack, and then we will need to write the 4 functions that are typically required for the operations of that stack. The function push, which adds an element to the stack, function pop, which removes the topmost element, the element last added, a function top, which gives me the topmost element without removing it, and finally, we will need to have a function is empty or empty, which will tell me whether there is at all any element in the stack. So, if is empty is true, then operations like pop and top will be invalid, because there is no top element to remove or to return. So, we can note that as we change the type of elements for a stack, we need to re-implement, rewrite the whole code of the stack. That is, the code of the stack for stack of integers and the code of the stack for stack of strings would be different, though the basic notion of the LIFO will be valid in both cases. So, unlike say sine, square root, all these functions that we have in C standard library, we have taken a look earlier in math.h, we have a lot of library functions. So, if I want to do compute sine or compute square root or compute arctan, I do not need to write that function. I can just use it from the library. In contrast, C standard library does not give me a mechanism to use a stack. It does not give me a stack which I can use right away. So, this is the current state of affairs with the C programming. So, in this context, we would try to take a look as to how things can change if we use C++. So, let us also take a look in some of the common problems that we try to solve using a stack. Given a string, I would like to reverse the string, that is the left to right order, I would like to change to right to left order, is a typical program. Another is evaluation of a postfix expression. As you all know, typically we write expressions with infix notation, where the operator happens in between the operands. So, I am showing an example 1 plus 2 star 3 minus 4. If I have to evaluate this expression, though we read the expression from left to right, when we go to evaluate this, we will not strictly be able to evaluate left to right. We know that the multiplication has a higher precedence compared to addition and subtraction. So, first we will have to multiply 2 with 3, get the result 6, and then we have a plus and a minus, which both of which has the same precedence, but they are left associative. So, we will have to proceed from left to right and compute that, and the result will turn out to be 3. So, infix notation is very good in terms of how we write an expression. We have been taught from our school days to write this expression and follow the so called BODMAS rule to evaluate it. But it gets very difficult for evaluating a postfix expression, because the order of the operators to be executed varies in between depending on their precedence and associativity. So, we take resort to a different notation known as a postfix notation. In the postfix notation, it is first the operands are specified and then the operator comes, that is why it is postfix. So, always if I see an operator, then the operands for that have already occurred. So, if the operator has an arity 2, then I know that 2 immediately preceding operands are to be applied for that operator. So, we show an example here, where you can see that if I look into say this expression, which is converted from the infix expression as given here, my expression turns out to be 1 2 3 star plus 4 minus, and this is also a problem as to how to convert the infix expression to a postfix expression. That also can be solved by using a stack, but here we are just showing that if the postfix expression is given, how do we evaluate it using a stack. So, these are the different stack states. All that we keep on doing is we scan the expression from left to right, take every operand, put it into the stack, keep on stacking till we come across an operator. So, here we push 1, then we push 2, then we push 3, and then we come across the operator star, which by definition has arity 2. So, I know that it will require the last 2 operands. So, we pop these 2 and 3, apply the operator to get 6 and push it back. Then we get plus the next operator. So, we know that also needs 2 operands. So, we pop 6 and 1, the stack becomes empty, we operate it with plus to get 7 and push it back, and we proceed in this way to get the result. So, this is a nice example to see that we need different need to proceed using the different functions of the stack to actually compute the expression, postfix expression that is available to us. Similarly, several other problems like identification of palindromes, which read the same from both sides, with or without a center marker, that is a special character at the middle, can be identified by using stack. Infix expression can be converted to postfix, depth first search can be done, and examples are several. So, stack plays a significant role in the programming of any software system, and therefore, if we can have convenient, reliable, robust mechanisms to use stack, we will be strongly benefited, and this is what C++ gives us as a ready-made solution. So, let us take a look at reversing a string. This is more of a recap for you. This is a C program which is trying to reverse the string. As you can see, there are the stack is defined as a structure which is has an array, which is the container of the elements, and a marker which is a top index, which will keep the current index of the topmost element. And these are the implementation of the 4 functions: empty, top, push and pop. Empty just checks if the top value is -1. -1 designates that there is no element, because the minimum index value in the array could be 0. So, if it is -1, then we designate that the stack is empty. The top simply returns the element from the top position. Push increments the top position and puts the new element which has been given to be added to the stack onto the stack, and pop simply decrements the top pointer or the top index, so that the element that was considered to be the topmost is not considered topmost anymore. The element just below it is considered to be the topmost, and since we cannot do this operation if the stack is already empty, it will be good to check if the stack is empty before we actually perform the pop operation. Now, this is we all know this. So, here using that if we have a string A, B, C, D, E here, we can just go in a for loop, add all these characters A, B, C, D and E one after the other into the stack, and then if we keep on finding out the top element and popping that top element, then certainly E has been added last. So, that will come out first, D has been added just before that. So, it will come out next, and in result we will get the string that we are showing here, which is EDCBA, and we all are familiar with this. So, this is the way. If you have to do the reverse string program, then it is not only that you have to write this main function or the function which uses the stack to reverse the string, you also need to write the code that is given on the left column. That is a scenario in C. A similar scenario is given for evaluating postfix expression. Again in C, left column is identical to the previous example, where the implementation of the stack is given, and on the right column we show how we can use this to actually do the postfix evaluation. This is just the code of the algorithm I explained a couple of slides back. You can go through it and understand that this will actually do the job for us. It does the operation of finding if something is an operand, which is done at this point. If you just look at particularly focus at this point, you will see that here we are identifying if the character that is given in the expression is a operand or not. So, it is considered to be an operand if it is a numeral. So, in this expression we find out if is digit is CH, that is whether it is a digit, can be an operand, single digit operand, and then we push it. Otherwise, we consider, we know that it is an operator, and according to what that operator is, it finds out and takes the topmost elements, pops them out, and then computes the result and pushes it back. The general code of postfix expression would be much more complicated, because you will have to also consider the arity of the operator and then do things based on that. Here we know all 4 operators, expected operators are binary. So, all those checks are not here. Okay. Now, let us move on. So, what will happen in C++? In C++, the good thing is the C++ standard library provides us with a ready-made stack. So, to create that stack or to use that stack, all we need to do is to include a new header called the stack header. Instantiate the stack which is defined in that stack header, and then just start using the functions of that stack object, and we will have the stack ready for us. So, here we are showing the reverse string example again. On the right is the C program. Of course, the stack codes which we have already discussed are not shown here. It is just the use of the stack in terms of doing the reversing of the string is shown, and an equivalent code is written on the left hand side. Here, please note that in the C++ code, we do not need to write the stack codes. Instead, all that we are trying to do is we include a specific header. This is not the one, this is the header, include stack. This include stack header we have included, which includes the stack definitions, and this is how we instantiate the stack. This is, you had seen this notation earlier when we talked about vectors in contrast to arrays. You had seen that if I have a vector, then I could put the element type within the corner bracket. Similarly, if I have a stack, within this angle brackets, we are showing what is the type of the element that the stack will be made of, and the stack object's name will be S. Now, if you look into how we use this here in C, if we have to push, we have to pass 2 parameters. We have to say what is the stack, which is the address &s, and what is the element that we want to push. Here we simply do s dot you had seen this notation also briefly in the context of vector, but we will talk about this lot more, but this is a typical notation, the notation like what you use in structures, but somewhat differently interpreted. S dot push, which says that in stock S I want to push, and what do I want to push? I want to push the str I, that particular element. Similarly, if I want to do this here, I want to do check for emptiness, I do empty ampersand S. In contrast here, I will do S dot is empty, as we can see here. So, you can see that in terms of the code that use the stack, the code is very similar, and actually as we will understand, the code is simpler to write, because I do not have unnecessary parameters as in C, where I have to pass the parameter, the pointer to the stack at every point, and I can just keep that outside of the function call and just pass the parameters that are needed, which is in case of push is one parameter, in case of the rest no parameters are required. Finally, also note in C, while we define the stack, we also needed to initialize the top marker to -1. Here somehow the system takes care of it, the compiler takes care of it. So, I will not need to bother about initializing this top marker. So, in brief, if we use the stack from the standard library, then we do have a lot of advantage of not having to rewrite the stack codes every time we have a new type of data to deal with. These points are highlighted at the below here, and instead we have a well tested ready made stack available for use. I will just proceed this here. If you look into the next example, this is again similar to what we did in C, but now we are doing it in C++ for the postfix evaluation, expression evaluation in postfix notation, and this code is again very similar to the C code that we had written, with the exception of having to include the stack header, define the stack with this notation, and then all the stack functions are similarly written in a little bit different format, but the code otherwise is as it were in C, and with the advantage that we do not have to do anything in terms of the stack code implementation. So, in this module, what we have shown is, if you are programming in C++, then you get a major advantage in terms of using stack. You do not need to implement the stack code, you do not need to even be concerned about what should be the maximum size of the container for the stack. The C++ standard library stack automatically takes care of that. It takes care of how to initialize the top, and it can be used for any type of element that I want the stack for. And the very interesting and exciting part of the whole C++ programming and standard library is that the story does not stop just with stack. All common data structures which are frequently required, like queue, which is first in first out, dq, which is double ended queue, where you can add and remove at both ends of the sequence, the list, the singly linked list, the map, which is like name value pair, set, where the ordering is not important, you can just do union intersection in that. All of these data structures are available ready made in the C++ standard library. So, as we start programming in C++, even before we have understood the detailed nuances of the programming language, we would like to frequently take a look at the C++ standard library and write programs making use of all these data structures and make our programming easier and more robust to use.